Okay. Hi, I am sorry. Sorry for the previous live. It's just the networks went something wrong here. Okay. I think the sound still. Okay. Seems like there's no way I can go back to the previous video to comment out at this moment, so I gotta continue with this one. Let's say this is the version 2 for the previous video. Yeah, I'm so sorry for that. Okay, yeah. Let me just get the URL for this newer live stream to the previous one. Okay. Well, all right, and let me see. Okay, I'm so sorry for the people who have been watching the previous one. I just seems to lost the network. I'm not really sure why. I'm using like a machine to stream, which is not affected by my PC, but it just went wrong somehow. Yep. Okay. Sorry for that. Okay, well, I am. Let me just update the information for this stream. I'm gonna name the title of this live as part 2. Okay. So, people who haven't watched the previous live, maybe you can go back to see the one for the part 1, and then you can continue watching this one later, since I'm gonna keep this as an archive as always, so you can always go back and see what I have explained if you are interested. Okay, so sorry. Now let's continue, but we were almost at the end, so I think it's not a big I hope it's not a big problem. So where was I? So I was looking at this bunny. So I was trying to show you how you can do the differential growth on the 3D geometry instead of the 2D plane. Okay, now I have just copied the setup from the 2D, the disk setup right here, to the 3D here. So what I'm gonna do next is to see what I need to change inside the code. And I think there's not much things to change here. So I have these code to define the position of the strength, stretch lines, you getting a UV, getting the reference positions from the reference geometry, reference bunny geometry, then get the distance. All right, now using, okay, so I guess this is going to work as it is. Okay, and for this one, for the stretch, let's make sure that I am looking at the bunny. This one as well. For the input, ref bunny. The binding is constraint geometry, that's fine. And all the other stuff, you can just use it as it is, I think, for now. Okay, I think there's not much things to change, just these input value to reference bunny. And that's probably it. All the stuff is pretty much the same, so let's see what's going to happen here. Play it, and hopefully only the blue part is going to grow and the red part will remain the same. Now I have some problem right here. Maybe it's because of the adaptive remesh. Don't like that. Maybe I can set the adaptive remesh or the gradation of the to be something a bit more gradual, like these. And maybe apply some seed to test out the different positions of, oops, not right here, but right here inside the noise. Okay, now let's see. This one, if I play it, okay, I still see some weird thing happening. It's not from the remesh, I guess. It's probably because of the UV that I'm using, because I'm using the UV flatten right here to create a UV on this bunny, and when I use the UV sample to get the reference positions from the UV, might get some weird point positions. To check that out, I can go back to right here. Okay, first of all, it seems like I have this UV on a vertex. Maybe I might want to place this on a point, which might not be the reason, but let's try to do that first. So attribute promote from vertex to point. I'm going to promote this UV. Okay, now the UV has been transferred to the point. Now let's see if it's going to fix. Nope. Okay, so other things that I can check is I'm going to write the similar code that I wrote here in order to reference the UV sample, which is this one right here, outside of Vellum, to check if I'm using the UV correctly. Okay, so let's copy this one, going inside the geometry, and let's do this for this constraint that I've created. So primitive wrangle, connect this constraints to the right here, and only look at the stretch, and copy paste the one that I've just copied. And what I want to look at, these are okay, just getting the point positions, and what I want to check is this one. UV sample is getting from probably this mesh. So, and for the third input, this is the reference geometry, which is the bunny, so this one to the third input. Okay, so this should give you the same result, and as a result, the distance that I got here, I'm going to, since the bunny hasn't been transferred yet in this case, the rest it the distance should be equal to the rest length, but if it's different, then I'm having some buggy uh, effect here, something that I saw on the bunny's ear. So let's see, let's name this the rest length 2 and compare with the rest lengths, original rest lengths. For the primitive, going into the rest length 2 right here, only for the stretch, so I'm going to delete, I'm going to pick only the stretch group. And let's see, let's compare. If anything is different between rest lengths and rest lengths 2, then that's a problem. Okay, seems everything is okay, something is wrong because the maximum value of the rest length 2 is 1.4. The maximum for the rest length 1 is 0.6. So I think at some part you have a obvious difference between the rest length and rest length 2. That is because of the way it uses the UV. Okay, so that's a bit of problem. So what you could do, you could try using a other remesh pattern, maybe changing the gradation a little bit and see what happens. If it doesn't solve, then okay, now this one, okay, yeah, I still see some problem here. It's a little bit of difference here, but the most of the part looks okay, so maybe this gives you a better result. Let's see. So one thing you really need to be careful is that you have a clean UV. I mean, currently I have just using the UV flatten to create a kind of a dirty way, kind of fast and dirty way to create a UV. So that's kind of a why it's creating this kind of differences, because you can see that the UV has been distorted over a geometry. Now this is the result that I'm having. So the blue part is the one that's scaling up, and the red part is the one that's keep it scale. As you can see, you start to see some interesting squashed surface. Alright, like it. Anybody want to, anybody would like to 3D print it. Okay, and as you can see, every 20 frames it is adaptively remeshing, and that's pretty useful to do simulations like this in order to make a partial growth, to make to keep the quality. Okay, so I guess that's about it, what I wanted to explain for today. I am really sorry for the network issues here. I do want to solve it if I know the reasons, but currently I don't really know the reason why I got into that problem. But hopefully it doesn't work. Hopefully it doesn't happen next time. Okay, well, let me know if anybody's here and anybody have any questions, please ask. If not, hopefully you'll find it interesting. Hope you find these live tutorial interesting, and I would like to continue doing it until I found it bored. Okay, as always, I'm going to keep the video as an archive. This time, I there is part 1 and part 2 since I had a problem with the network. So I'm going to make a link to both of the parts so that you can go from both of the video to the previous or the next one. And I'm also going to upload the file that I have just created so that you can check it out and like modify it for your purposes. I think the steps that I shown you could be really like flexible, could be used for many other usage, not just for the differential growth, but in order to control different types of constraints together with the adaptive remeshing. Okay. All right. So hopefully I'll do that. Okay. I have a questions from Fred. I have a questions. Does it would be a solution to fill a leg of muscle? That it would be a solution to fill a leg of muscles? Oh, could be. Yeah. Not sure how exactly it could be used, but it could. I guess it could be used. I haven't got any idea. I can't think of any idea at this moment, but yeah. I think this system is flexible enough to simulate that kind of stuff. Right, well, thank you everybody for the comments. I really appreciate it. And I'm sorry for people who have missed this live, especially who was in the previous live, was listening. We'll try to, hopefully it doesn't happen again. Okay, well, so if you like the video, I would appreciate if you press the like, and if you are interested in those kind of tutorials, I will. I have started the Patreon myself, so if you could support me, that would be also great. Okay, thank you, and I'll see you next week. Okay, and thank you for watching.